Hi, this is Mrs. Clark, and welcome to the third part of our segment addition postulate notes. So this is examples 5 and 6. We're going to go over the midpoint. So we have learned previously about midpoints. Midpoints are the point in the middle of the line segment. We just finished talking about segment bisectors over here. Midpoints are very similar. If you notice the picture looks almost exactly the same, except they're telling us that M is the midpoint instead of telling us that a line is cutting through, or a ray, or a segment, and chopping the line segment in half. So what's different is we're given information that this point is in the middle versus something coming through and cutting it in half. Either way, it's the same outcome. So when I have a midpoint, if M is our midpoint in this picture, I have two pieces that are equal to each other. AM is going to be equal to MB. So the length of AM is the same as the length of MB, and that's what these little tick marks mean. I just don't have another figure coming through, cutting it in half. I just know that this point is exactly in the middle. So that's going to help us out when we go to do example 5 and 6, because our diagrams are going to be very simple. So I'm going to draw my line segment AB and put M in the middle, as close to the middle as I can make it. But knowing that I'm not perfect and I can't make it exactly unless I'm using a ruler, I'm going to mark this side AM the same size as that side. So I'm going to put double marks on both. You could put single or double or triple. As long as they match, then we're good. It also tells us that AM is 7x plus 4, so I'm going to label that here. And MB is 9x minus 16, so I'm going to label that here. I do not have the total for how long AB is. In fact, that's what I'm trying to find down here. So I'm not going to be able to use our segment addition postulate and say AM plus MB equals AB, because I don't have the total for AB. But since I know I have a midpoint, I know that AM is equal to MB, so I'm going to use this type of equation. And by setting up this letter equation first, now I can fill in my algebraic expressions underneath it to give myself an equation so that I can solve for x. Once I find my x, then I can figure out how long AB is. So AM was 7x plus 4, so I'm going to write that right here underneath. And that should be equal to MB, which is 9x. Oh, I forgot. It's a 16 here, so make sure you have a 16 there. MB is 9x minus 16, so I'm going to put 9x minus 16 on this side of the equal sign. In order to start solving this for x, I look to see if there's parentheses, which there aren't, so there's no distribution. I look for combining like terms, but if I look where my equal sign is, on this side I have a number and a variable, so those are not like. On this side I have a number and a variable, so those are not like. There's no like terms to combine. So the next thing I would look for is to move my variables together. I have 7x's here and 9x's there. I'm going to take the smaller one, which is 7x. I'm going to move it over here. But because I'm crossing the equal sign, I'm going to have to use inverse operations. It's a positive 7x, so I'm going to subtract 7x. And I'm going to do that on both sides of my equal sign. So minus 7x, and then again underneath the 9x, I'm going to put a minus 7x. When I do that here, this becomes 0. 7x minus 7x is 0. And I'm left with just a 4 over here. That's going to be equal to 9x minus 7x, which is 2x, minus 16. So now I have to solve this problem for x. I've done my moving the variable. Don't Call Me After Midnight says the next thing I should look for is addition and subtraction on the same side as the x. So here's my variable. Over here it's subtracting 16, so I'm going to undo that by adding 16. I'm going to do that under the 4 also to keep it balanced. 4 plus 16 is 20. That's going to equal 2x. And negative 16 and positive 16 is 0, so that goes away. Now to finish up, I've got 2 times x. I need to do the inverse of 2 times. So I'm going to divide by 2 on both sides of my equation. 20 divided by 2 is 10. 2 divided by 2 is 1, so this is 1x. 10 is equal to x, or x is 10. Either way, however you want to say it. So I found x equal to 10. That's the first step. The next thing that I'm going to want to do is find the length of AB. So AB goes from here to here. I need to find AM, I need to find MB. Once I have them both, they total up to whatever AB is. So I'm going to do that by finding the length of AM. And so I'm going to say AM, we know, is equal to 7x plus 4, but we just figured out what x was. So since x is 10, I can put that in here and do 7 times 10 plus 4. So 7 times 10 is 70, plus 4 is 74. So I know this side is 74. This side is the same thing, so they're both 74. So if I want to know AB, it's 74 plus another 74. So to find AB, I'm going to do 74 plus 74, and that is 148. So AB is 148 units long. So we're going to take a look at example 6, also using the midpoint, and kind of wrap everything that we've been doing together. So if you can, take a second and pause the video, read this part, and draw yourself a diagram, and then check back to see if you did it correctly. E is the midpoint of DF. So I'm going to make a segment DF. I'm going to put E as close to the middle as I can. And because it's the middle, I'm going to put those tick marks. DE and EF, I'm going to mark them the same. DE is 5x plus 4, so it's going to go here. And DF is 78. So DF is actually the whole thing from here to here. That's what's 78. So it's a little bit different about this problem. If you notice, up here I had both of the pieces I had an expression for. Down here I only have an expression on this side. I don't have anything here. But I have a total, which I didn't have before. So even though DE is equal to EF, that's a true statement because this is E is the midpoint. This isn't going to help me build an equation where I can find x, because DE and EF don't have two different algebraic expressions on them. I just have 5x plus 4 over here. But I do have the total. So I want to think back to that segment addition postulate work that we did at the beginning, where we said DE plus EF equals DF. And we know that DE is 5x plus 4. And we know EF is the same thing, so I'm going to write plus 5x plus 4. I'm going to write it twice. Equals DF, which is 78. So I'm going to label EF as 5x plus 4 because they are the same thing. They're equal to each other, so they can both get the same label. Alright, so what that means is I have now an equation here where I can solve for x. If I'm looking at my equal sign way over here, there's no parentheses, so no distribution, but I have a lot of terms here. So some of these are like terms that can be combined together. I've got 5x and another 5x, so that makes 10x. I got positive 4 and another positive 4, so that makes positive 8. So 10x plus 8 equals 78. So I combine my like terms. All the x's are already right here. So my next step is to try to get rid of this added 8. So the inverse of adding 8 is subtracting 8. Subtract 8 on both sides of my equal sign. 10x, this will cancel out and be 0, equals 78 minus 8, which is 70. Then I'm going to divide by 10 to get x by itself. X is going to equal 70 divided by 10, which is 7. So in this problem, x equals 7. And now I'm asked to find DE. DE goes from here to here. It's 5x plus 4. So if I want DE, I'm going to do 5 times my x plus 4. So 5 times 7 plus 4. So that's 35 plus 4, so that's 39. So DE is 39. And there you have it. So thank you for watching my video on finding the midpoint using segment addition. Let me know if you have any questions, and then get to practicing so you can be an expert on this by the time we have our test. Thanks for watching.